Hi, Assalamualaikum. My name is Ahmad Arsyad and I'm from Squad Sigma Group. Today we want to talk about our MA123 group project. Okay, right now I will introduce to you guys member of Squad Sigma. First we have our leader, which is Shu. Second have myself, Achat, and have Errol and Dino. Firstly, I want to talk about introduction of geometry. Did you know geometry word can be separated into two words that have different meaning, which is geo mean earth and metron is measure, and that word come from Greek word. In ancient, the Egyptian, the Romans, and the Greeks use geometry in the world of architectural construction. Historically, geometry began as a practical discipline for measuring land and constructing buildings, but over the time it evolved into more abstract branch of mathematics that study the properties, relationship, and measurement of shape, space, and position of figures. Since geometry was used in architectural world, many objects was formed by combination more than one polygon. We were assigned to study about objects that have combined two or more polygons. In this video, we will talk about history and we will do some calculation of the object we choose to study about. Okay. After make discussion with group member, we already choose two objects. First is Eiffel Tower. Second is camera tripod. So now let's move to the history.
History of Eiffel Tower. The Eiffel Tower is an iconic structure located in Paris, France. It was constructed as the centerpiece of the 1889 Exposition Universelle to celebrate the 100th anniversary of the French Revolution. It designed by Gustave Eiffel Engineering Company. Then, the Tower of Primary Engineer was Maurice Koechlin, and the chief architect was Stephen Sylvestre. Its construction began in January 1887 and was complete in March 1889. It just taking over 2 years. At the time of its completion, it was the tallest man-made structure in the world at 300 meters. A record it held until the Chrysler Building in New York surpassed it in 1830. During World War II, the French cut the tower's elevator cable to prevent German use. It became a symbol of French resilience and pride, appearing in countless artworks, movies, and literature. Today, the Eiffel Tower is one of the most visited monuments in the world, with over 7 million visitors annually. It has undergone several renovations and repainted approximately every 7 years to maintain its iconic look.
So, how to calculate the area and the volume of Eiffel Tower? First, we can divide it into sec. For example, these two are the congruent, the shape are congruent, so we can make it as sec A, and this is B, and this two also is similar, which we can make as C and D, E, F, and G. So first we will calculate by sec. For example, we will calculate the sec A first, which is the shape is actually a parallelogram, which the formula is A equal to base time height. The height is 19 degrees. So the base is 25.63 and the height is 44. And then it have two same object which needs to times by 2. So we get the answer is 2255.4. What about B? B is an isosceles trapezoid, so we're going to use area formula of trapezium, which is B equal to 1/2 A plus B times H. So how to get the base this? First, we need to add it all up, 25.63 plus 40.809 and same as this. And we get 92.069. And we will do the same here and we get 62.7. And then the height is 80. So by putting on calculator, we will get 1392.921 meters square. And for C, sec C, it's actually a trapezium, not a parallelogram, because the base here is 15 and this is 11.32, so it's not a parallelogram but it's trapezium. So we use the formula, the trapezium formula, and times it by 2 because it have two same shape. So the base is 15 and the other base is 11.32 and the height is 43.2 meter. So the total of area is 1137.024. More about sec D. D is also a trapezium. So we're gonna just use the same formula as before and just put the value of this, total of this, which is 38.82 meter and plus 31.204 meter times with 14.9 meter, and the value is 531.6788 meters square. For the E, it's also a trapezium, and we just going to use the same formula and just put the value and we get 3122.9974 meters square. And for F, sec F, is a rectangle, so the formula is base times height. So 10.8 meter times 31.23, which we get 337.284 meters square. So we're just gonna add all this up and this, and then we get the value, the summation of it, which is 8767.3052. So for the sec G, it's actually not a rectangle but a cylinder with one base. So the formula is 2 pi r plus pi r squared because it only have one circle. So we just add the value, and the 2 is a diameter, but so the radius is diameter divided by 2, which is 1. We got all the values now and we just add it all up. So this is only one-sided of Eiffel Tower, so we need to time it by 4. This, all of this, from F to A, time it by 4. And that's plus G, which is 191.4487, and then plus the area of the red one, which is 113.4984. And then the total area is 35,374.1679 meters square. And then how to calculate the volume of Eiffel Tower? We can just assume it as pyramid. So the volume of pyramid is 1/3 times base area times height. So the base area is the base of Eiffel Tower is square, which is 92.069 times 92069, or we can write it as square. And then the height is 300 meters, so put on the value in the formula and then calculate. We get 847,670.0761 meter cube.
History of tripod. In ancient origins, the earliest tripods were used in prehistoric time, primarily to support cooking pots over a fire. In ancient Greece and Rome, tripods were symbolic and ceremonial, often used in religious rituals. The Delphic tripod, for instance, held the seat of the oracle at the temple of Apollo. Additionally, ancient cultures, including in China, utilized tripod for scientists, experiment, and alchemical purpose. In Renaissance to early modern period, during the 40 to 70 centuries, tripods were used to support scientists' instruments such as telescopes and surveying tools. In the 80s and 19th centuries, invention of photography further popularized tripods as they were essential for stabilizing the bulky early camera for long exposure shots. In modern era, in the late 20th century, tripod became even more advanced with the use of carbon fiber, making them both lightweight and durable. Modern features include quick-release plates, ball heads, and flexible legs for diverse applications. Smart tripod with motorized control, gyroscopic stabilization, and app integration have become popular in photography and videography, catering to professional and hobbyists alike. Finally, in conclusion, the tripod is a timeless tool that has evolved significantly, reflecting humanity's needs for stability in the both practical and creative pursuit. Its adaptability and innovation ensure it remains essential across industries and applications.
So I will show you all how to calculate the surface area and volume of tripod. First, let's see the diagram. The diagram shows that the tripod have 4 congruent legs, and the leg of the tripod is cylinder. The diameter of the leg of tripod is 2, so automatically the radius is 1. The height of the leg of the tripod is 45. For the middle part of tripod, we have another cylinder, and the diameter of the middle cylinder is 4, automatically the radius is 2. The height of the cylinder is 10. For the top of the tripod, we have cuboid. The base of cuboid we have 4, and the height of the cuboid we have 10. So let we enter all the information into the formula. The formula of area of cylinder is 2 pi RH plus 2 pi R square. So to find a leg of tripod, we will use the information, which is 2 pi times 1 square plus 2 pi times 2 times 45. So we will get 289.0265. Because of the tripod have 4 congruent legs, So we must multiply the answer by 4.
and we will get 1156.106. For the middle cylinder, we will use the same formula, 2 pi times 2 square plus 2 pi times 2 times 10. We will get 150.7964. So the formula to find the area of cuboid is base times height.
So our base of cuboid is 4 and the height of the cuboid is 10. So we just need to multiply the two information and we will get 40. To find the total surface area of tripod, we need to add all the information. So 1156.106 plus 150.7964 plus 40, and we will get 1346.9024. So let me continue to volume of tripod. Let's assume that the tripod is similar to pyramid. So the volume of pyramid is 1/3 times base area times height. So we can easily find the base area first because we have the information, which is 30 times 30, and we will get 900. And to find h, we need to use the theorem Pythagoras. So set 65 square minus 15 square, and we will get 63.2456. So we can enter all the information into the formula, and volume of pyramid is 1/3 times base area, which is 900 times 63.2456, and we will get 18,963.68. So that's how we do. Thank you.
Finally, we have arrived to our final agenda, which is conclusion. Our conclusion is geometry is a branch of mathematics that studies shape, size, and properties of space. It helps us understand and solve problems involving lines, angle, surface, and solid in the real world, such as designing, building, mapping, or creating art. That's all. Thank you.